Bench testing a 1963 Cadillac non-fog light option headlight switch, serial number HSGETT98, offered by TT Parts Rebuilding. Run-up test. Test number 1, tail and parking light operation. Test number 2, tail and headlight operation. Test number 3, dome courtesy light operation. Test number 4, dash lights set low to high. Test number 5, circuit breaker test. And test number 6, switch terminals insulated from ground. During the run-up test, we're going to be using a fully charged battery, and we're going to be boosting the battery. The run-up test. Right now we're reporting around 1302 volts. Also going to monitor the rheostat temperature. Right now we're at ambient Fahrenheit degrees, 82 degrees. On the boost, we're around 14.27 volts. Test number 1, tail and parking light operation. First position, we have our tail, parking lights. We're going to rotate the rheostat and set the lights on the dash to dim. And off. Again, first position, tail and parking light operation. Tail and parking. And off. Test number 2, tail and headlight operation. First position, we have our tail and parking. Second position, front parking lights come off and we have our headlights are on. Back to first position, headlights come off, parking lights come on and off. Test number 3, dome courtesy light operation. First position, you rotate the rheostat to the bright position on the dash lights and then ground the tab for the dome courtesy lights. And off. Second position, that feature is also available by rotating the rheostat and indication of dome courtesy lights. Back to first position and off. Rotate the rheostat stem here. We're going to turn on the dome courtesy light. And off. Test number 4, dash lights set low to high. First position, we have our dash lights are set on high right now. We're going to set it to mid-range. Park that there for a few seconds. Monitor the rheostat temperature. We're picking up a little bit of temperature in the rheostat core. And then about 87 degrees. Let's put this on dim. Let's sit there for a few seconds. See the temperature of the rheostat come up a little bit. Dim position. Mid-range. Full bright. Second position. Headlight position. We have full bright dash lights. Mid-range. Dim. The off position. Back to the lowest setting. So your dim setting. Mid-range. Back to first position. And off. Test number 5, circuit breaker test. Velcro Rummy headlight switches had a built-in circuit breaker. It's a bimetallic contact arm that connects the battery to the switch. Can demonstrate a situation if there's overheating in the headlight circuit or the light circuit of the vehicle. We'll put this in first position, and we're going to demonstrate a simulation of expansion of the contact arm. And we see we have a disconnect between the battery and the switch. This protects the switch and the vehicle wiring. The feature is also available in second position, headlight position. Demonstrate a simulation of the contact arm. We see we have a disconnect between the battery and the switch, protecting the body of the switch and also the vehicle wiring. And off. Test number 6, switch terminals insulated from ground. This test we're going to be using a standard 12-volt test light. We see we have continuity back to the battery at the switch chassis. And probe each one of the switch body terminals to demonstrate the switch terminals insulated from ground. Starting here at the parking lights, we see we have no continuity back to the battery. Here's our tail light, no continuity back to the battery. Headlight, no continuity back to the battery. Our battery feed, no continuity back to the battery. Dash light feed, no continuity. Courtesy light ground tab, no continuity. The only continuity we have back to the battery is at the switch chassis. This demonstrates that the switch terminals are insulated from ground.